Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and here we are going to find out the value of this integral using the concept of beta and gamma functions. So we have to evaluate the integral 0 to 1, and we have dx over the sixth root of 1 minus x raised to 6, right? So let us first convert this integral I using the method of substitution to the beta function, which is given by beta m comma n is given by the integral 0 to 1, and we have t raised to m minus 1 minus t raised to n minus 1 dt. So the first step is to convert this integral by method of substitution to this integral, and then we'll apply the properties of beta and gamma functions, right? So let us take this integral as I, and here what we will do, we'll first write this integral I as 0 to 1. We have dx divided by 1 minus x raised to 6 raised to 1 over 6, and let us make this substitution, that is t is equal to x raised to 6, so that we can write x is equal to t raised to 1 over 6. Now let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 over 6. So using the method of power rule, that is the derivative of t raised to n is given by n times t raised to n minus 1. So we have n is equal to 1 over 6. So we have 1 over 6, then t 1 over 6 minus 1. So we have 1 over 6, and t raised to 1 minus 6 over 5, that is 1 over 6 t raised to here we have 6, and then we can write minus 5 over 6. So now we can write dx is equal to 1 over 6 times t raised to minus 5 over 6, and here we have dt. Now let us change the limits accordingly. So here x varies from 0 to 1. So when x is equal to 0, the value of t can be obtained from this relation. So we have t is equal to 0 raised to 6, that is simply 0. And when t is equal to 1, then we have t is when x is equal to 1, then we have t is equal to 1 raised to 6, that is simply 1. So when x varies from 0 to 1, then t varies from 0 to 1. So now let us write the value of this integral I in terms of t. So we can now write I is equal to 0 to 1, because the limits remains the same, and we have for dx we can write 1 over 6 and t raised to minus 5 over 6 dt, and in the denominator we have 1 minus t, because x raised to 6 is t, and here we have 1 over 6, right? So now taking 1 over 6 outside the integral, we have 0 to 1, and then we have t raised to minus 5 over 6, and taking 1 minus t raised to 1 over 6 to the numerator, we can now write 1 minus t raised to minus 1 over 6, and here we have dt. So now we can easily observe that this integral is similar to this one, that is the beta function, that is beta m comma n is 0 to 1 t raised to m minus 1 1 minus t raised to n minus 1 dt, where m and n are greater than 0. right? So here we have t raised to minus 5 over 6, and here we have t raised to m minus 1. So now we need to find out the values of m and n. So we can compare this integral with this one. Here we have an additional factor 1 over 6. So now m minus 1 can be written as minus 5 over 6, and n minus 1 can be written as minus 1 over 6. So let us solve these two equations. So we can now write m is equal to minus 5 by 6 plus 1, that is minus 5 plus 6 over 6, that is 1 over 6. So the value of m is 1 over 6, right? And from this equation we can now write n is minus 1 over 6 plus 1. So n is minus 1 plus 6 over 6, that is 5 over 6. So we can now write n is equal to 5 over 6. So now we can write this integral as 1 over 6, 0 to 1, and t raised to minus 5 over 6 is m minus 1. So we have m is equal to 1 over 6. So 1 over 6 minus 1, and here we have 1 minus t raised to minus 1 over 6. So minus 1 over 6 can be written as n minus 1. So we have n 5 over 6, and this is minus 1 and dt. So now this integral is exactly similar to this one. So we can now replace this integral by the beta function. So we have beta m comma n. M is 1 over 6 and n is 5 over 6. So now we have to find out the value of this expression. So to get the value of this expression, we'll make use of an important relation between beta and gamma functions. So gamma beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So now using this relation, we can now write 1 over 6. Then we have gamma 1 over 6 times gamma of 5 over 6 divided by gamma 1 over 6 plus 5 over 6. So now we can write 1 over 6. Then this is gamma 1 over 6 and gamma of 5 over 6 divided by 1 over 6 plus 5 over 6 is 6 over 6, that is equal to gamma 1, and gamma 1 is equal to 1. So here we have 1. So now we can write the value of the integral I as 1 over 6 gamma 1 over 6 and gamma 5 over 6. Now to get the value of this expression, we have to make use of the famous Euler's reflection formula. And the reflection formula goes like this: gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? So if we take this n as 1 over 6, then we have gamma 1 minus 1 over 6, gamma 1 over 6, and here we have pi divided by sine n pi. So n is 1 over 6, so we have pi over 6. So now this is 1 minus 1 over 6, so this is gamma 5 over 6, and here we have gamma 1 over 6, and this is pi divided by sine pi by 6. Now sine pi by 6 is sine 30 degrees, that is equal to half. So here we have half, so this is equal to 2 pi, taking this 2 to the numerator. So the product of gamma 5 over 6 and gamma 1 over 6 is equal to 2 pi. So substituting this value over here, the value of the integral I is now 1 over 6 times 2 pi, and we can now cancel this 6 by 2. So we have here 2 times 3 is 6. So this is pi over 3. So viewers, the value of this integral is equal to pi over 3. So this is how, by making use of the concept of beta and gamma functions, we can easily evaluate integrals of this kind. Hello viewers, in today's session we have another important and interesting problem from beta gamma functions, and here we are going to evaluate this integral that is from 0 to 2 x raised to 5 over 2 divided by square root of 2 minus x dx with the help of some concepts from beta and gamma functions, right? So let us start. So let us first take this integral as I, right? Now here what we will do, will first make use of the method of substitution, right? And by using the method of substitution, we'll convert this integral into this form, that is the beta function, that is beta m comma n is given by the integral 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So here we'll substitute x is equal to 2 times t, right? And using this substitution, we'll convert this integral into this form. So here x is equal to 2t, and t can be written as x over 2. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of 2t, and then we can write 2 times d by dt of t, and the derivative of t with respect to t is 1. So we have 2 times 1, that is equal to 2. So now we can write dx is equal to 2 dt. Okay, so now here we'll change the limits accordingly. So here the lower limit is 0 and the upper limit is 2. So when x is equal to 0, then the value of t can be obtained from this relation. So t is equal to 0 over 2, that is 0. And when we have x is equal to 2, then the value of t can be obtained from again from this relation. So we have 2 over 2, that is 1, right? So now let us write this integral in terms of d. So now we can write the integral I as 0 to 1, and here when x changes from 0 to 2, t goes from 0 to 1, and for x we can write 2t. So we have 2t raised to 5 over 2 divided by square root of 2 minus 2t, and here we have for dx we can write 2 dt. So let us now simplify this expression. So we can now distribute this power, that is 5 over 2 over 2 and t. So we have 2 raised to 5 over 2 t raised to 5 over 2. Here we have 2 raised to 1 and dt, and in the denominator we have square root of 2 times 1 minus t. So taking 2 common in the under the square root sign. So now we can write 0 to 1, we have 2 raised to 5 over 2 and t raised to 5 over 2, and here we have 2 raised to 1, and taking square root of 2 to the numerator, we can write 2 raised to minus half, and here square root of 1 minus t can also be taken to the numerator. So we can now write 1 minus t raised to minus half, and here we have dt. So now let us further simplify it. So here we can collect all these 2's. So we have 2 raised to 5 over 2, then we have plus 1, and then we have minus half, and here we have t raised to 5 over 2 and 1 minus t raised to minus half, and here we have dt. So now simplifying this term, so we have 2 raised to, here we have 5 over 2 minus half is 4 over 2, that is 2, and 2 plus 1 is 3. So we have 2 cube, that is equal to 8, right? And taking 8 outside the integral, we have 8 times 0 to 1 and t raised to 5 over 2 and 1 minus t raised to minus half and dt. So now let us write I is equal to 8 times the integral 0 to 1, and t raised to 5 over 2 can be written as 7 over 2 minus 1, because 7 over 2 minus 1 is equal to 7 minus 2 over 2, that is 5 over 2. And here we have 1 minus t raised to minus half, and minus half can be written as half minus 1, and here we have dt, because half minus 1 is equal to minus half, right? So now we can see that this integral is similar to this one, right? And here if we compare this integral with this one, then here we have 0 to 1, 0 to 1, and t raised to m minus 1. So here we have t raised to 7 over 2 minus 1. So comparing, m is equal to 7 over 2, and here we have 1 minus t raised to half minus 1. So here we have 1 minus t raised to n minus 1. So comparing, again comparing, we can now write n is equal to half, right? So now we can write this integral I as 8 times the beta function, that is beta 7 over 2 comma half, right? So now we have to find out the value of this expression by using an important relationship between beta function and gamma function. So beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So here we can now write gamma 7 over 2, then gamma half, and then we have gamma 7 over 2 plus half, right? Okay, so now let us find out the value of gamma 7 over 2. Now gamma 7 over 2 can be written as gamma 5 over 2 plus 1, and here we'll again make use of an important result, that is gamma n plus 1 is given by n times gamma n. So here the value of n is 5 over 2, so we can now write 5 over 2 times gamma of 5 over 2, and again we can split 5 over 2 as 3 by 2 plus 1. So again applying this result to this one, so we have 5 over 2 times 3 by 2 and gamma 3 by 2. So let us further write gamma 3 over 2 as half plus 1. So we can now write 5 over 2 times 3 over 2 times half, and then we have gamma half. So here again we have used this result, right? So now this is 5 times 3 is 15, and here 2 times 2 times 2 is 8, and gamma half is given by square root of pi. So now in the denominator we have gamma 7 over 2 plus half. So we have 7 over 2 plus half is 7 plus 1 over 2, that is gamma 7 plus 1 is 8, 8 over 2, that is gamma 4, and gamma 4 is equal to 3 factorial, that is equal to 6, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer. So now we can write the value of this integral I as 8 times gamma 7 over 2, which is 15 over 8, and here we have root pi, and gamma half is square root of pi, and divided by this expression, and this is equal to 6, right? So now this 8 and this 8 get cancelled, and we have 15 over 6. Root pi times root pi is pi, and again simplifying, this is 3 times 5, and 3 times 2 is 6, so we have 5 pi over 2, right? So viewers, the value of this integral I is 5 pi divided by 2.